Hello student, welcome to all of you in our YouTube channel Laksh Be Invincible. Today we are going to learn about kinematics because you all know there are upcoming examinations are NDA and Air Force. And for both the examinations, the physics plays very important role, and the part of physics, kinematics, is very important topic for both the defense examinations. Kinematics have 1 to 2 questions ratio in NDA examination and also in Air Force examination. Now, we are going to start with how to learn kinematics and which type of questions are asked from this topic. So let's start this topic. First of all, we talk about the frame of reference. What is the frame of reference? Frame of reference is simply a place from where we observe to others. For example, when we are in a platform, when we are in a station and standing in a platform, then what we tell to others? We tell to another person then when the train is coming. When the train is coming, but when we are in a train, then what we talk to others? We tell which station is coming. So, what is the difference between these two sentences? The difference is this: when we are in a platform, then we take ourselves as a rest. And for our frame of reference, the frame of reference is platform, and for this frame of reference, train is in motion, and train is another frame of reference. But when we are in a train, then we take train as a frame of reference, and for this frame of reference, we think train is in rest and surrounding is in motion. So what is the frame of reference? It is just a place from where we observe to others. The difference between motion and rest is also defined by frame of reference. So when we talk about the rest, so what is the rest? In the whole universe, there is nothing which is in rest. Everything is in motion. So why we called something is in rest? You think I am in rest and I think you are in rest because we both have same frame of reference. You are in also earth and I am also in earth. So both have same frame of reference and we think we are both are in rest. But when I change my frame of reference from earth to moon, when I am going to moon, then from moon what we can observe? We observe that when I am in moon and you are on earth, then from moon I see you are in motion and you see I am in motion because we change our frame of references. So frame of reference defines the motion and also defines the rest. Depends on the position of frame of reference. Now, when we talk about what is motion, so motion and rest both are relative to each other and is defined by these examples. When we talk about this diagram, then think that when time is 0 second and when time is running, time is becomes 0.25, 0.5 or 0.75. Then what we observe? When any object change its position with time, then we called it's in motion. But when an object cannot or does not change its position with time, then we can say it's in rest. Now, for this example, we see that the car is in rest. Why? Because with time, car is not moving. But when car starts moving with time, then we called it's in motion. So how can we define motion? Motion is when someone or something change its position with time, then we called it's in motion. But when someone or something is not changing its position with time, then we call it in rest. Next example we can take. Now, see this particle. This particle is in rest with time. Time is increasing, but particle's position cannot be changed. But when we change the position of the particle with time, then we can tell the particle is in motion. So I think you will understand the motion and rest and how can we differentiate between these two. Now, we talk about position vector. Position vector is the coordinate axis which defines the position of any object from the observer. We can take observer as the origin point and the position of any substance what we can observe, then the position of this substance from this origin is defined by position vector. The coordinates of this dog from the origin, when dog is in this place, is 10 meter in the x-axis. This is the position vector which defines the position of this dog. And when dog at this point B, then its position in y-axis plus 4 meter and x-axis is minus 5 meter. Its coordinates becomes minus 5 comma 4. And the vector which defines the position of this dog is called position vector. Okay. Now let's see another example. We can take ourselves as origin. We are observer and we observe the position of this dog in the positions A or B. The distance of these two dogs from origin is 10 meter and 20 meter respectively. Then this vector is defined the position of these two dogs. Then we call this vector as a position vector. Okay, I hope you will understand the position vector. Now we will talk about the scalar quantity or vector quantity. What is the scalar or vector? Simply, the physical quantities which are completely defined by only its magnitude are called scalar, and there is no need to define direction of these quantities. For example, when you go to a general store and ask for 1 kg of sugar, then what you tell? You tell to give me 1 kg of sugar. Okay? You need only magnitude of sugar. There is no need of direction. Please give me the sugar in west direction or please give me the sugar in north direction. There is no need of direction, only magnitude. So these physical quantities which are completely defined by only its magnitude are called scalar quantities. There are more examples like mass, speed. Speed is also a scalar quantity because it defines only the magnitude. In your car or bike, you have a speedometer which shows the speed, only magnitude of your car or bike, not the direction in which direction you are going, it can tell. Okay. Now, there are another examples like distance, time, volume, density, temperature, and all other things. But what about these quantities which need direction also? So these quantities which need magnitude and direction both as well as, then these quantities are called vector quantities. Vector quantities are defined by magnitude and also these quantities needs direction. For example, when we talk about velocity have magnitude but also it needs direction for completely definition. Okay. Another examples are acceleration and electric force is a very basic example. When you going to any shop, then there are stick in a doors and the written matter in this doors are push or pull. When you push or pull the door will open. So what do you think? You think a push or pull is a force and force have a direction because push is also have a direction and pull is also have a direction. That's why force is a vector quantity because force is always acting in a particular direction. Electric field, magnetic field, polarization, momentum are also the physical quantities which need direction. Electric field also have a direction. Without any direction, it cannot move in a random motion. Okay. Now, let's take an exceptional case. Exceptional case, we are talk about electric current. Electric current. When we talk about electric current, so we all know that electric current have magnitude and also it has direction. Electric current has direction. So why we can tell the electric current is a scalar quantity? Why it is not a vector quantity? Why? Because we learned in previous the vector quantities are those which have magnitude and also as well as direction. Electric current have both. It has magnitude and also a direction. So why it is a scalar? So answer is very simple. Answer is it does not follow which law? Vector sum law. Vector sum law. That's why it is a scalar quantity. So what is missing in the definition of vector quantities? This vector sum law is missing. So what are the vector quantities? Vector quantities are those which follows vector sum law. When any physical quantity which is not following this law are not called vector quantities. For example, electric current is the best example. Electric current is a scalar quantity because its sums is algebraical. When we take an example, there are 5 ampere current is flowing in the wire and wire is break in two parts, A and B. So when 3 ampere current is going the wire A, so what amount of current is going in wire B? You can simply say that it's 2 ampere. So this is the addition or subtraction is algebraical. There are algebraical summation happen. That's why electric current is a scalar quantity. But when it is add algebraically, so it's scalar. But when it adds vectorly, then it becomes vector. That's why it's not a vector quantity. Okay. Now we are going to talk about distance versus displacement. What is the distance? Distance is the actual length or actual distance what we can travel. Distance is simply defined the actual length which we can travel. Okay. But what is the displacement? Displacement is the difference between initial point or final point, start or end point. Okay. Now take an example. When we start from point A and going to point B, okay, we take this path. This red line path shows the actual length which we travel. Okay. When you are going from your home to your school, then you're moving like this in a random motion. Okay. Your direction changes it at every point. See, let us see. Direction changes at every point. Okay. And this path is not depends on direction. That's why it is called distance. It is called distance because it is the actual path which we can travel. But what about displacement? Displacement is shown by this green line. There is a start point A and end point B, and the shortest distance between end point or start point is called displacement. It has a direction, that's why displacement is a vector quantity. Displacement is a vector quantity and distance is a scalar quantity. Okay. Displacement is the shortest distance, remember it. Okay. And it needs magnitude and also depends on direction. But distance is only depends on magnitude, it's not need any direction. Okay. Displacement is a vector quantity, that's why it's depend on direction. Okay. Now let's talk about something like distance is when you are in motion. So distance is always positive. It cannot be negative or zero. When you are moving, then distance is taken as always positive quantity. But when we talk about displacement, so displacement depends on direction. That's why it becomes positive, can be become negative, and also be zero. Displacement can be positive, negative, or zero, depends on the change in direction or your position. When we start from point A, let's take an example. When we start point A and moving randomly in all direction, this like, and after that returning at that point A. When we start point A and end at point A, then my initial and final position both are same. That's why displacement is zero. But distance cannot be zero when you are in motion. Okay. Now let's take an example which is like this. You have a start point, okay, and we take two distances 1 meter each in the both direction of x-axis, positive x-axis, and in negative x-axis. Okay, we have a small boy like Chotu. Okay, now this small boy is start moving. This small boy start moving and is moved to 1 meter from that start point in a positive x-axis. So what is the distance and displacement at point A? So its distance become 1 meter, but displacement become plus 1 meter because this boy moves in a positive x-axis. Okay, now the boy returning from that point A to the start point. So what is the distance and displacement at that point A start point? So its distance becomes 2 meter because distance is always positive, but displacement becomes 0. Why? Because he starts from the start point and end at the start point. Its position is not changed. That's why its displacement become 0. Now, the boy moving in the negative x-axis 1 meter. So what is the distance and displacement at point B? So we can tell the distance becomes 3 meter and displacement become minus 1 meter because direction changes. Okay, now the boy returning after point B at point start point. So what is its final distance and displacement at the start point? Its distance become 4 meter and displacement become 0 because he start from start point and end at also that point. So that's why displacement become 0 but distance become 4 meter. Okay, I hope you will understand about the distance and displacement. Now we are going to talk about speed versus velocity. What is the difference between speed and velocity? So simply from the formula we can define speed. Speed depends on distance. That's why its formula is speed equals to distance upon time. And when we talk about velocity, so velocity depends on displacement. And its formula becomes displacement upon time. Okay, speed depends on distance, that's why speed is also a scalar quantity, and velocity depends on displacement, that's why it is a vector quantity. Okay, if we talk about units, both have same units, meter per second in SI system and meter per second in SI system. And when we talk about dimension formula, then it becomes LT minus 1 and LT minus 1 for both the quantities. But velocity is different from speed in the direction only. Okay, velocity having direction, but speed having only magnitude. So we all know distance is always positive when we are in motion, so speed can take positive always. Speed is always positive. But when we talk about velocity, it depends on displacement, then velocity can take as a positive quantity or it may be negative quantity. Okay, depends on direction. When we are moving in the opposite direction, then velocity take as a negative quantity. But when we are moving in a positive direction, then velocity can take as a positive quantity. Okay, now this is the difference between. Okay, now there is a one question arises. What is the question? Question is when the speed and velocity becomes equal. So what your answer? So you can tell when we are moving in a straight line, from A to B, then we can tell distance is equals to displacement, and when distance becomes equals to displacement, then speed becomes equals to velocity. But this sentence is completely correct? No. Why? Because when we are tell only moving in a straight line path, then we can travel also in the opposite direction. It can be happen. So what we can add? We tell when we are moving in a unidirection straight line path, then distance becomes equals to displacement. Okay, when distance become equal to displacement, we are moving in a straight line in unidirection path. Unidirection. Okay, when we are moving in a unidirection in a one direction straight line path, then distance become equals to displacement, and then speed becomes equals to velocity. Okay, okay, now there is a simple example which differentiate between velocity and speed. This is the speedometer. You all know the speedometer is situated in your car and bikes and also all the things. So speedometer what shows? It shows the speed of your vehicle. It shows only speed. Why? Because it shows only magnitude. Let's see. There is the speedometer reading shows 100 miles per hour or 160 km per hour. This is the only magnitude. That's why it is called speedometer. Speedometer. But in the second photo, you can see velocity. Why? 500 miles per hour. It's a speed, but it add west. It is a direction. When we have magnitude and direction both, then we call it's a velocity. Velocity can be represented by v vector, and speed is represented as a simply v or as a mod of v vector. Okay, this is the speed. What is the speed? In a one line definition, we can say that speed is the magnitude of velocity. Okay, and v cap represents the direction. It is a unit vector. Okay, it represents the direction. It represents the magnitude, which is the speed. So we can say velocity is the speed into direction. When we add direction with speed, it becomes velocity. That's the simplest difference between speed and velocity. Now, we are going to talk about what is the average speed and average velocity. So, simply from the formula, we can define the average speed and average velocity. When we talk about average speed, its formula is the total distance upon total time taken. Okay, this is the formula for average speed. And when we talk about average velocity, its formula is total displacement upon total time taken. Okay, now take an example and we can define completely. Okay, now when someone starts from point A and going to point B, the distance between point A to B is 400 kilometer and the time taken by the person is 5 hours. Okay, so the speed is, we all know speed equals to distance upon time, then 400 upon 5, this becomes 80 kilometer per hour. Okay, so which speed is this? This is an instantaneous or average? This is an average speed. Why? Because we learn the formula. Average speed is the total distance upon total time. We have total distance from point A to B, which is 400 kilometer, and the total time taken by the person to travel this distance is 5 hours. This is the total time. So when we divide total distance by total time, we got always the average speed. When you start, let us consider, when you start from Kanpur to going to Delhi, the average distance between Kanpur to Delhi is 400 kilometer and the average time taken, it's 5 hours. Then 80 kilometer per hour becomes your average speed. Why? When you start from your home, then your speed becomes 10 to 20, between 10 to 20. Then you increases your speed with the traffic, according to your traffic. When you are on highway, then your speed may be 100 plus kilometer per hour. Or when you are in a heavy traffic, your speed becomes 0, it will be 0 or 20 or 10. So what tells average speed? It tells when you are traveling with 80 kilometer per hour, then you will get 5 hours to travel 400 kilometer distance. Okay, that's why it is called average speed. And we are talking about average velocity, then also this phenomenon is happened with velocity. Okay, now you have some numerical problems. Okay, and how can you deal with these numerical problems? In a very simple manner with time, because time is a very important thing in all your competitive examination. When you take time, your competitive examination becomes very worse for you. To reduce the time and with full accuracy, how can you solve the numerical problems? So I can tell you. Okay, let an example first. We have 2 points A and B. Let distance between these 2 points is capital D. We differentiate these 2 points in half part of distances, D by 2 or D by 2. Okay, let this point is C. Okay, first half portion is covered by 40 km per hour speed and another half portion is covered by 60 km per hour speed. So your question is, what is the average speed of the person? So how can you calculate? You learn the formula average speed equals to total distance upon total time. Okay, total distance upon total time. You have total distance is capital D, but you don't have total time. So how can you take it time? Now, from A to C, distance, the time, it's T1. Time equals to distance upon speed. We can use this formula, distance is D by 2 and speed is 40 km. So time T1 becomes D by 80 hours. Similarly, from C to B, the time is T2, formula is same, D by 2 upon 60. The time T2 becomes D by 120 hours. So the total time capital T equals to T1 plus T2. Okay, we can add both the times, we get 5T upon 240 hours. This is the total time. Now, put these values in formula. Capital D is the total distance, total time is 5T upon 240. Now, you can solve this and got 48 km per hour. This is your average speed for this problem. But this is the basic method and it's very time consuming. How can we reduce the time? Because time matters. So we use some short tricks. This is not short trick, this is a concept, but we can use generally a word short trick. So how can we solve this in very less time? When we talk about distance, and distance is divided into two equal parts. It divides in two equal parts. So how can we calculate average velocity? So average speed of velocity formula is 2v1 v2 upon v1 plus v2. Now apply this formula in previous question. We get v1 and v2. v1 is 40 km per hour and v2 is 60 km per hour. Now put the values. 2 into 40 into 60 upon 40 plus 60. It's become 2 into 40 into 60 upon 100. The zero cancels each other and it becomes 48 km per hour. This is the simplest method to solve this type of problem. But this applicable only when distance is divided into two equal parts. Remember it. Now, when distance is divided into three equal parts, it divides in three equal parts. So, how can we calculate average speed? So, formula becomes 3 V1, V2, V3 upon V1, V2 plus V2, V3 plus V3, V1. This is formula for when distance is divided into three equal parts, and more than three it cannot, this type of problems is not used in the competitive examination. Maximum is divided in two equal parts or in three equal parts. Now another thing is this, when we talk about time, when time divides in two equal parts, when time divides in two equal parts, So how can we calculate the average speed? Average speed. Average speed formula when time divided into equal parts is simply add both the velocities and divided by 2. Okay, when we talk about 3 equal parts, when time divides in 3 equal parts, so average speed becomes v1 plus v2 plus v3 divided by 3. Add all 3 velocities and divided by 3. When becomes more than 3, then add all the velocities and divided by number of velocities. This is the simplest method to solve problems like this, in which time is divided into 2 or more equal parts and distance is divided into 2 or more equal parts. But when the question have not divide the time and distance in equal parts, so how can we calculate? Then we use simple method of addition. Average speed equals to total distance upon total time, on total displacement upon total time. Now this is the last point of today's lecture. Now we in the next lecture we are going to learn about instantaneous velocity. How can we calculate the instantaneous velocity, and we talk about the acceleration and the relation between all these things. Okay, I hope you will get the complete information about this topic and you will understand this in very well manner. And thank you so much guys for watching today's session. Now we meet in the next session and talk about instantaneous velocity or speed. Thank you so much.